creative part, I'm going to be telling you about how the generators at Hoover Dam make electricity and what processes lead to the generators making electricity. So in my right hand, I have a water bottle and a straw. This represents the intake tower and pipes at Hoover Dam. In my left hand, I have a generator. This will represent the generators at the bottom of the dam. So if I just let the water flow like this, you can see that the light on the side is not lighting up. This is because there is not enough energy or speed for the water to push the turbines fast enough. So let's see, if I squeeze this, the light will light up. This is because the water from the top of the dam has more energy or more power to be used to push the turbines. That's why the light can light up. So the dam was built there not to just block water, but to raise the water level on one side so the water can use gravity to its advantage to push the generators. Okay, so if the generators can create electricity, how? You see this yellow thing, it would be like a turbine pushing it, and the bottom is the generator. What is going on inside of the generator? Well, inside the generator, it consists of some magnets and a metal coil. So there are two magnets on the side of the generator, one here, one here. They are opposite poles, so one's north, one's south. Between these magnets, there are magnetic fields between them. They're just straight across like this. And in between, there is a coil, a metal coil, and the coil is connected to the generator, which when it spins, it will spin the coil. When the coil spins, it will cut the magnetic field. When the magnetic field is cut, it will generate a current within the coil. When the current is generated in the coil, it can be transferred through wires and transferred through wires to power grids, and then to cities, buildings, to be used for charging, cooking, and all of those, all the stuff we use today that needs electricity. So it's already turned into electricity once the turbine spins the coil and it cuts the magnetic field. So the generators are considered a big battery. So now if the generators are considered a battery, then where's the positive end and where's the negative end? Well, according to Faraday, there's this right hand rule. It is where you have, it's the same concept like this, but I can show you in a different model. Let's say you have a U-shaped magnet, a metal bar, and movement of the metal bar to generate the current you need for electricity. So let's say the magnet, north, south. Current always flows from north to south. So from up to down. And now you place the metal bar in the middle. The metal bar doesn't do anything by itself, but if you move it a direction, let's say out of the magnet, it will generate a current. So the magnet's inside, the rod is inside, and it goes out. Now we're determining positive and negative end, so we need to know which direction the current flows. You can find it using the right-hand rule. The right-hand rule is using your right hand, you place it in the magnet or your left hand, which represents the magnet. North, south, it goes down. the magnetic field should be going through your palm, like from up to down, facing your palm, like this. So you place it like this. And now the rod is moving out of the magnet, and your thumb will show that direction the rod is moving. And now these 4 fingers right here, this will show the direction of, like, it's going like this, it's pointing this way. It will show the direction of the current made. So then if you just connected wires from the front and the back to a light bulb, it will light up because you move it. So when it's always from positive, go back, and negative. So this side's positive, where the direction starts, like where it comes out. And when it goes back in to the rod, that's negative. In conclusion, this is how the generators at Hoover Dam work, but in reality it's much more complicated, but they still follow the same principle. Thank you.